Welcome, my dear students. First Secondary Rajak Language School. We will meet with the second video, specific heat. Specific heat is the quantity of heat required or needed to raise or increase the temperature of 1 gram of the substance, not water. Calorie, again, calorie is the temperature or quantity of heat required to raise the temperature of 1 gram of pure water. Here, specific heat is the quantity of heat needed or required to raise the temperature of 1 gram of the substance by only 1 degree Celsius. This is specific heat. After that, the unit used in measuring specific heat is joule per gram degree Celsius. Specific heat differs accordingly with the type of the substance. Here we will stop. If we have any question, the question is specific heat of the substance depends on its surface area, its volume, its mass, its type. Yes, excellent, its type. So a specific heat depends on the type of the substance only. It is constant for the same substance. Constant for the same substance. The mass, if the mass is changed or the temperature is changed, for example, a piece of iron, but a specific heat of the piece of iron doesn't change or is not affected. Specific heat is a constant value for the same substance, and it is different from substance to another. Another property of a specific heat, if the substance has large specific heat, needs a large quantity of heat to rise its temperature, means needs a large time or longer time to be heated, such as water. Water has the highest specific heat of all other substances, that equals 4.18 joule per gram times degree Celsius. This needs long time. It may also take a long time for the substance to lose this heat once more, in contrary or in opposite of the substance that has less specific heat. Here this table shows that aluminium specific heat is 0.9, carbon and so on, copper, iron, water. Here water or liquid or water in gas. Observe that or note that water in gas 2.01, water in liquid 4.18. This means that specific heat of the same substance differs by its physical state. Water here in liquid state has 4.18 specific heat, while water in water vapor or gaseous state has specific heat equals 2.01 joule per gram degree Celsius. Calculation of a quantity of the heat absorbed or lost from the relation QP equal MC delta T. QP is the quantity of heat lost or gained under constant pressure. M, this quantity of heat by joule. M, mass of the substance by gram. C, specific heat by measuring unit joule per gram degree Celsius. Delta T is the change in temperature equals T2 minus T1. T2 final temperature, T1 initial temperature. As QP represent a quantity of heat at constant pressure, M is the mass, and C is specific heat of the substance. Delta T is the difference in temperature. It is calculated from the relation delta T equals T2 minus T1, as T1 is initial temperature, while T2 is the final temperature. After that, we will identify, my dear students, calorimeter. Calorimeter provides us isolated system that allows us to measure the change in temperature of the isolated system, as it prevents the loss or gain of any quantity of heat or substance with its surrounding, as we previously studied in the last video. The calorimeter allows us to use a certain amount of substance where heat exchange takes place with it. This substance is most likely water. Why water? Because it has, or due to its increase of its specific heat that allows it to gain or lose a large quantity of heat. The change in temperature is calculated by calculating the difference between the final temperature and the initial one, delta T. There are other types of calorimeter called pump calorimeter used to measure the heat of combustion of some substances. In pump calorimeter, reaction occurs or takes place with a known amount of the substance needs to be burned in excess amount of oxygen under constant atmospheric pressure. It is placed, the substance is placed in isolated steel container called the steel pump. The substance is ignited or burned using electric wire. The steel pump is surrounded by identical amount of water as previously said. As we said previously, water has higher specific heat that allows it to lose or gain large amount of heat energy. Calorimeter components or structure. The calorimeter components is composed of or constructed of insulated container, a thermometer, and stirrer and stirrer for stirring. A liquid is placed inside it, which is most likely to be water. These are the two types of the calorimeters. Number one, the first type is at the right side, our right hand side is called coffee cup calorimeter. The left hand side is the pump calorimeter. Multiplication product of the mass M in specific heat C is known as heat capacity C. Example, on dissolve 1 mole of ammonium nitrate formula is NH4NO3. In an amount of water, complete the solution volume to 100 milliliter of water. You note that the temperature dropped or decreases from 25 degrees Celsius, this is T1, to 17 temperature, this is T2. Calculate the quantity of absorbed heat. Here in this solution, we consider water as diluted solution. This means water density or diluted solution density equals 1 gram per 1 cubic centimeter or per 1 milliliter. This means that if the problem is given 100 milliliter, whatever milliliter here means the mass. So volume equal to the mass in case of water and in case of diluted solution. Volume equal to mass or mass equal to volume. Why? Because water density or solution density equals 1 gram per 1 cubic centimeter. 1 gram per cubic centimeter means the mass is the volume and vice versa. So here in diluted solution, the mass of a millimeter of water is calculated to equal 1 gram because the water density is 1 gram per milliliter. A QP equal 100 times specific heat of water mass MC delta T, M 100 gram times C specific heat of water or diluted solution equals 4.18 times T2 minus T1, T2 17 minus 25 equal negative 3,344 joule, divided 1,000 to convert it into kilojoule per mole equal negative 3.344 kilojoule per mole. After that we will identify heat content. Lesson 2. Heat content. Each chemical substance differs in the number and type of atoms included in its structure. It also differs in the type of bond between its atoms than the other substance. So each substance has specified amount of energy called internal energy. Internal energy. The amount is the summation of the number of types of energy stored inside the substance. So energy or internal energy inside each substance may be stored in 3 types. Number 1, stored chemical energy in atom. Stored chemical energy in molecules. Number 3, stored chemical energy between molecules. So stored chemical energy in atom is represented in electron energy in energy levels. That includes the summation of kinetic energy and potential energy of electron in energy levels. This is called stored chemical energy in atom. Number 2, stored chemical energy of or in the molecule means the chemical energy in molecule is found in chemical bonds between atoms of the molecule, whether they are covalent bonds or ionic bonds. Number 3 may be energy stored in or as intermolecular forces. The attraction force between the molecules is known as van der Waals attraction force. It is considered as potential energy. There are other forces between molecules like hydrogen bonds. These forces depend on nature of molecules and their polarity. So from the previous we can clarify that the substance stores amount of energy that is produced from the electron energy in energy level of the atom, energy of chemical bonds in molecules, and energy of attraction between the molecules. The sum of these energies found in 1 mole of substance is called what? Heat content of the substance, or molar enthalpy. Molar enthalpy, heat content of the substance H, or molar enthalpy. It is the sum of stored energies in 1 mole of a substance. Here we will stop, and after that we will continue or complete the heat content. See you later, inshallah.